Okay, so let's go ahead and get started. So my name is Dan McPherson. This is Krishna Raman. We're both developers who work on OpenShift. Let's start with a few quick polls here. So one, who made it to the pub crawl last night and actually made it here? A few people. I'm impressed. I did not. I called it early night myself. Okay, so next question. How many of you would consider yourself developers? Okay, quite a few. How about operations, sysadmin type people? A lot of you as well, a little bit more of you. How many of you are familiar with PaaS already? How many of you are using a PaaS? Okay, how many of you are using OpenShift? Handful, okay, it's quite a few new people. That's good. Okay, so let's talk a little bit about what we just open sourced. So a year ago, I guess a year and a month ago, we released OpenShift, the hosted solution. And we spent the last 12 months trying to make that a world-class service. And we knew, being Red Hat, right, that we had to eventually open source it. And it was going to be a tough challenge because there's a whole lot of moving parts to OpenShift as far as the amount of software that's involved, the amount of packages. And at the same time, it's a little difficult because it's a hosted service that we've built inside of existing infrastructure. And we knew this was going to be difficult, but at the same time, again, we know we're Red Hat, and we know we have to get it open, and so we made the effort and we made it happen. And what we released is OpenShift Origin. So you can go now to github.com/OpenShift, and you'll see a number of projects out there. So the main one that actually has the majority of server-side code is the crankcase repository, and that has both the broker and the node components inside of that repository. There's a few other components that exist out there for the client tools, a DNS plugin, and there's a large number of quick starts that exist in that same organization in GitHub. So whenever we built OpenShift from the beginning, it was very important to us to get user feedback. And the whole time we've done the hosted service for OpenShift, we've paid a lot of attention to what users were actually using and asking for. So we pay attention to the surveys and do the best we can to get the requested features out there. The same thing's really going to apply to the open source. The whole point of getting it out there is to really get community involvement. We want to get as many people involved in the open source project as possible. We're doing all of our main development out in the open source. And we absolutely invite all of you to take a look at what's there. If you want to see changes, feel free to request those changes. Feel free to submit pull requests. We'll be glad to take a look at anything you want. And really, we've just begun. So there's a huge portion of the code out there now in OpenShift Origin, the vast majority of it. There are still a few things we're working on moving to there because in some cases we're having to push code upstream. A good example actually is the M-collective logic, which allows us to do multiple nodes. That's going to be released very shortly into the open source in the coming weeks. And since now all of the new work that we're actually doing inside of OpenShift is being done in the open source for the long term, you'll be able to follow the open source and know what everything is happening in the hosted solution essentially. Okay, so let's do a little level setting here. So most of you are pretty familiar with PaaS, but I want to make sure that we're all on the same page before we go deeper into the architecture. So rule number one, it's important to know that infrastructure as a service is very different from platform as a service. With infrastructure as a service, you're really focusing on virtual machines. With platform as a service, the real focus is on application, about defining what an application is. And it's not necessarily the case that those applications will map one-to-one with a virtual machine. And we'll get into greater detail on that in a moment. Oops, should press more buttons here. Okay, so rule number two, PaaS is not a silver bullet. It's something we believe that's going to really transform the industry over the coming years and has a lot of benefits, but it doesn't solve every single problem for you. So what it is really good for is self-service environments. So cases where you have lots of people that you want to be able to deploy lots of applications. Because the role of the PaaS is to define what an application is and help the management of those applications, it enables you to allow the actual deployers to be able to quickly push new applications to the cloud, quickly be able to do all sorts of pretty sophisticated operations with them with usually simple checkboxes. So like you can say, I want HA, and that would be a checkbox, or I want scale, and I want to scale up to a certain amount. Those type of things become very easy with a PaaS, require much less intervention for operations to make that happen. It's also very good for varied and volatile workloads. So whenever you have sorts of situations where you need lots of load for a very short period of time, so say, for example, you need to have an integration environment for a few days or a stage environment for a few days, you can spin those up, do whatever testing you need to do, and spin them back down completely. Same thing is true for if you have something which you have peak load, so Christmas shopping, for example. You're expecting to have lots of load during those time periods. That's one of those things that a PaaS is very good for, because you're only essentially having to pay for what you're using. So if you if you need to scale up, then you only pay for the scale up size when you're actually using it, which is great. It's also great for polyglot environments. So because you're defining a very strict rule of what an application is, you're able to handle lots of varied applications at the same time. So polyglot is just meaning that multiple languages are supported. And the OpenShift frameworks currently support around 6 languages and a few different versions of some of those languages. Okay, and it's also very good for standard deployments, meaning, again, because we're defining what an application looks like, it is the case that you want for the things that are deployed on the PaaS to not be overly complicated, right? So if your use case is, I need a 16 gigabyte heap and I need to set 14 kernel parameters before my application will even run, then a PaaS probably isn't the right place yet. Maybe in a few years, those types of scenarios will be handled. But what's really there now is sort of best of breed technologies, right? So if it's the either latest and greatest or best supported, like so, for example, on the OpenShift PaaS, what's supported is the same things that are supported in the base operating system largely. So whatever version RHEL is supporting is the versions that you'll see on OpenShift. And same thing with Fedora and OpenShift Origin. All right, so rule number 3, PaaS is about developers, but it's also about operations. So it's about developers from the perspective of it's really enabling developers to be able to quickly deploy. At the same time, though, it's really changing how operations is working. A lot's happened over the past 10 or 15 years to make development a lot easier. Not a lot has happened, though, to make the communication and the interconnect between operations and developers a lot easier. And that's really what a PaaS is doing, right? So a lot of you may find this pretty familiar, I guess. It's I guess a funny little slide here I like to say, which is some people will look at this different way. Some people will say that a PaaS is going to get rid of operations, right? The goal there is basically that you want to have operations totally automated to the point of you can deploy anything easily. I don't necessarily think that's the case. I think it's more the case that you're changing the interaction between operations and development, where you're making it much easier to take your applications and get them deployed from a development perspective. At the same time, your operations is really changing what they're doing. So instead of having a ticketing system where you have to whoever from engineering has to open a ticket and say I need X, Y, and Z deployed, and then a week later the new machines are racked and everything gets deployed. It's more of operations job with the PaaS to be able to monitor how much is happening, making sure that the resources are allocated appropriately, making sure that there's enough additional space for whenever new applications come in that they'll have space available. And so in that respect, it's revolutionizing what operations does to some extent. It by no means gets rid of the job. So rule number 4 is be ready to learn. And this is sort of a view of what developers would expect out of a platform as a service. They really expect to be able to, with some sort of check marks, in this case it's a configuration file that's describing what types of things that they want to happen when they do the deployment. So you see here examples like picking what language you want to use, picking whether it scales, picking whether you're using continuous integration, such as Jenkins. It could be check marks there for what availability zones you want, whether you want high availability, whether you want all sorts of things. And all of these are what really a PaaS is trying to provide easily, right? It's trying to provide the logic to be able to define what is possible in some sort of language that the deployer of the application can actually use. From an operations side, what's really changing here is, again, that definition of defining an application in a very familiar way, right? So, and what that does is it says it's a language that development and operations can communicate in, right? They both know exactly what shape an application looks like. And that shape is the same whenever it gets deployed in production as it is whenever it gets deployed for development. And the other big change here is multi-tenancy. And so what a PaaS is really bringing as well is the ability to manage applications with multi-tenancy. This has a huge number of advantages. So some of you may not be familiar with multi-tenancy, so let's go into greater detail there. Okay, another picture for you. So this is sort of our view of what a lot of server environments currently look like. You have a lot of systems. There's applications running on all of them. They all have some amount of additional space there, just in case the applications that are running on them happen to need more available bandwidth or whatever. And most of them are drastically underutilized. It's funny because I've been a developer pretty much all of my career, and every single system I've ever worked on, the bottleneck for the system, as far as keeping it from getting to its maximum performance, has always been the CPU. But it's interesting that every single operations person I've ever talked to, that's not the case. The bottleneck is always, is never the CPU. They'll tell me that every system they ever monitor, the CPU is at 1 or 2% usually, right? Which means that most systems out there are drastically underutilized. And so this is sort of what we view as another way of looking at that same picture from a platform as a service perspective, and particularly a multi-tenant one, where you have less systems that you need to manage overall. There's a lot more going on inside of those systems, though. And so so in this case, right, you have a lot of examples where with a multi-VM system, you have every single VM that you have has another operating system running on it, right, which is another gig or so of memory, and whatever application it may be running. You maybe do a little bit of multi-tenancy there, meaning running a couple of applications on a single VM, if you don't have to worry about them interfering with each other. But not a whole lot of sharing. If you need another application, you typically are going to spin up another VM. With multi-tenancy, you can run a lot of applications inside of the same VM, and so you get advantages of you don't have to respin the operating system again. So that's the 500 megs or a gig or so for just the OS. And then as well, you also have shared memory advantages of all the applications of common types can share various libraries in memory, which is another huge advantage. And so, and at the same time, there's one more big advantage there of the extra space that's available. You only have to have enough available for some of the applications to grow in size. Right? So if you're dealing with where you have an application essentially per VM, you pretty much have to have a little bit of extra space for every application. Right? Whereas if you put lots of applications together inside of a single system in a multi-tenant system, then you can have enough extra space so only a few of the apps will actually. On average, if you have to understand your systems, but on average, you can basically have enough space so some of the apps at any point in time can increase. And that's, again, where still some operations is still needed to be in the fray. I think over time, even PaaSes will get even more advanced and be able to help automate some of those features. But that's some of the huge advantages there of using a PaaS, and particularly a multi-tenant PaaS. Okay, so at this point, I'm going to let Krishna take over. He's going to start going into a little bit more of the deeper level architecture of OpenShift origin.
Okay. So let's start by defining what an application is. An application to me consists of two parts. The first part is the runtime. This is what is required to run the application. This would be the language that you're using, the database that you're using, and so on. And in OpenShift, all of these are provided to you by cartridges. The second part of the application is the code, and this is what the developer is providing. In OpenShift, we store all of the code in a private Git repository. There is one Git repository per application. And what this allows is maintenance of history. So every check-in and every commit is available. If you pushed something that broke the application, you can always roll back to a previous point. All of that is there. It also allows for a distributed development model. So it's not tied to any one person. And Git also makes it extremely simple to actually publish the application. All you have to do is commit your code and do a Git push. And at that point, it's pushed over to our system. It can go through continuous integration or whatever it has to, and then be published out to the web. Right. Creating an application then is also a very simple step. The first thing you would do is create a namespace. And this is basically providing a unique namespace under which all the applications are going to sit. It's a unique namespace per developer, so we make sure that applications' names don't conflict with each other, things like that. After you have a namespace, you would go about creating your application. You just have to specify the app name and the language that you want to use. And there are a whole bunch of languages available. There's also a DIY cartridge, and the idea there is if OpenShift doesn't support something you like, then you can always spin up something of your own. And I've created one using Dart. There are a whole bunch using Play and many other frameworks also available. Okay. So after the app is created and you have pushed it, it's already available to you. You can either curl it or you can go to it in a browser. And the URL is going to be your app name hyphen the domain name .rhcloud.com. But if you have your own URL, you control your own DNS, you can provide that also. So you just associate an alias with the application and point your DNS server to this, and it'll work that way. After that, you can go about adding any additional cartridges you would like. So in this case, it's adding MySQL. There's also a Jenkins client cartridge, which allows you to add continuous integration in. So what do you get when you create an application like this? You get basically a slice of the server. Right? And that slice, you can SSH into it. You can see exactly what processes are running there. You get a DNS for every application. And you get a private Git repository. This I talked about. Basically, every app has its own Git repository. No one else can look at it. This is not the same as GitHub. It's not public. And you get continuous integration. But what about scale, right? And how does all of this work? So there are two main parts in our system. The first one is the broker. The broker is responsible for the REST API front end. It does DNS management for the applications. It does the application lifecycle. It also has it keeps all of the metadata for the application in the MongoDB database, and we chose this because it was the best of breed scalable database out there right now. All of the communication from the broker to your applications happens over mcollective and over the Cupid message queue. Right? And the second part is the node. The node is the multi-tenant system that is being managed. Right? And it can run on a VM or it can run on bare metal. Really, we don't really have any restrictions as to where it can run. All it requires is an operating system underneath, and we rely on everything to happen from there. Right? So right now, OpenShift Origin runs on a Fedora 16 operating system, and it uses the SELinux policies from that. And our service is running on a RHEL 6 based release. So the way the multi-tenancy works is there are multiple applications, each running a process for whatever runtime they need to support. And in front of all of those, we have an HTTP proxy service. It's based on Apache. And this allows us to have one machine, whenever a HTTP request comes in based on the host name, we can direct it to whichever app it needs to go to. The node, when it is split up into smaller chunks, each of those chunks is called a gear. And the gear is where your code is actually running. Right? So if you look at this picture, you see the front end is basically the REST API. You use the REST API to talk to the broker. The broker is then using mcollective to talk to each node, and the nodes are running gears. The gear is nothing but a simple container model. That's what it really boils down to. Right? And within the container, we use SELinux to make sure that one application doesn't interfere with the other. It only has access to the resources that it needs to. We use Linux control groups to control the amount of resources available. So this allows us to control both memory and CPU and make sure that one application doesn't use up all the CPU on the system. We also use kernel namespaces and bind mounts to make sure the application has access to only the file system parts that it needs to see. So it can't really explore the rest of the system. Right? But SELinux and all of these container model things are there to restrict the application. So if you want to build a scalable application, these sometimes come in the way. So the way we have gotten around that is also we allow multiple instances of a cartridge to run on multiple gears. And only the ports that are necessary for those cartridges to talk to each other are open between these gears. This also means that no one from the outside can break in because very specific ports are open and only to the appropriate places. Right? Load balancing also happens in a similar way. So each gear exposes its HTTP interface, and there's an HA proxy sitting on a separate gear that is load balancing requests to all of these places. Whenever you do a git push, that pushes to the HA proxy gear, and that takes care of then doing the continuous integration, making sure that all the tests pass, and then pushing it out to the gears. So your application, if you have continuous integration added, your application will not go down while the build is happening. Even if something fails, the test fails, it won't push it. Okay. So we have all of these systems in place, but every organization is different. It won't fit everyone's needs. So we've made OpenShift pretty extensible. On OpenShift Origin, we have a bind-based DNS plugin. This allows us to very nicely encapsulate it within the live CD, or if you have it deployed on a multi-node setup, the bind basically covers everything within the multi-node setup. But this probably doesn't work for all organizations. You're probably running your own DNS servers, or you want to use something external. So there is a clean plugin API that you can write your own plugin for and connect it to your services. Same goes for the authentication plugin. So in Origin, we ship with a Mongo-based authentication plugin, but you're probably running Kerberos or Active Directory. So again, there is an extensible API for this. As far as security policies go, it runs in enforcing mode on Fedora. Right? But again, you can always lock down those policies further if you would like. You can restrict which cartridges are available to your system, or you can use community cartridges. Up to you. If we don't support something, you can always write your own cartridge and add it in as a runtime. If you are developing a framework, you can write up Quick Start and make it available to the community so that everyone in the community can now, within about 5 minutes, get started with your framework. Right? This goes the same way for internal development. If you need to do that, same facility. Okay, so next, Dan will cover some of the SELinux concepts in there.
Okay, so let's start with LXC. So LXC is what we really believe is the future of security here. And LXC right now, it provides great privacy and segmentation, a lot like the picture here with Japanese walls. But somebody really determined could get through those walls. And so what we really need in addition is SELinux. So SELinux is, for those not familiar, was developed by the NSA originally and was pulled into Red Hat and Fedora. I actually don't know exactly how long, but it was quite some time ago. And Red Hat's really embraced the technology. It's an incredibly powerful layer. And that's what we really need here, because with a multi-tenant PaaS, the real danger there is that your code is going to be running on the same instance, same node as a lot of other applications. And as the operations guy, as the developer guy, you really need to be comfortable with that fact. And it takes something at the level of SELinux for someone to actually get that level of comfort, and we'll talk about why. So in the end, we believe that LXC will integrate with SELinux well, providing what I believe is being referred to as secure LXC. And that, again, is going to be the future of having a multi-tenant cloud that you can actually trust the security of. However, we're not quite there yet. So the present is, again, that LXC is a great technology, but it's not really good enough to host your PaaS on by itself. So the present looks a lot more like this, where there's a lot of technologies. It really requires a core operating system level of understanding to be able to wire those technologies together and actually make something that can create a multi-tenant PaaS. Okay, so a little more detail there. So a lot of other platform as a service out there have gone with a model of taking some existing technology, whether it be Java or you name it, whatever framework you like, and they've taken those technologies and they've really stripped out functionality. So they've said, okay, this is something which is dangerous. Let's strip it out of the language or strip it out of the framework, and don't let people do it. And to some extent that works, but it has a lot of downsides. So one, it makes it so that whatever technology that they stripped out is no longer accessible. It means that whatever code you had written outside of the platform as a service may no longer work inside of that platform as a service. What you really want instead of that is you want for the ability to say, here's exactly the function that I'm going to allow, or whitelisting. And it just so happens that's exactly what SELinux is built to do. It's built to say, at an operating system level, here is the types of things you're allowed to do. And because of that, we're able to say, we don't care what the frameworks do running on the system. It could be absolutely any framework possible, and we know it's impossible for it to break any of the rules that the operating system defines. And those rules are what completely isolate the different applications from colliding with each other. Okay, so let's dig a little deeper into SELinux here. We're not going to go too deep. I know there's a Mortal SELinux talk going on nearby here. This is the one for Mortals, I think, hopefully. Okay, so step one is unlearn this. So I know a lot of you have probably done this. I've probably been guilty at some point in my life, and it's perfectly been acceptable for a lot of use cases. I think currently SELinux in a lot of use cases is a luxury, right? You have some boxes sit in some isolated network, and there's 12 levels of security before you get anywhere near that network, and you're not really concerned at this level of things of something at the operating system level actually being an issue. However, you have to be concerned about it whenever you're dealing with multiple applications running on the same system, right? At that point, you're already well past whatever outer security you had. And if you have an application which is trying to do bad things, you have to guarantee it can't do it. So we all have to be able to embrace SELinux. And you know who you are. Okay, so step two is learn the Z. So whenever you're doing listing files or listing processes, there's options for our capital Z to be able to do an ls-lz. Here's the example. And you see a little bit of information that's tagged along here. And actually, if you notice whenever you're listing files, actually I have a laser pointer. I think I do. Yeah, whenever you're listing files, there's a dot at the end of them, implies that a SELinux security context is actually set. So if you see that, you can do an ls-lz and see what the actual context is. So everything in between after the user there, or that's maybe the group, and before the file name is the SELinux context. And the same thing exists for whenever you're listing processes. So let's go into a little more detail here. Now, there's going to be a lot of information on this chart. Don't try to memorize the whole thing, but try to get the highlights here, especially related to multi-tenant security. So I think SELinux can be a little daunting at first, especially, I know it was for me even. It took me quite a few reads through the various documentation before I felt like I really understood it. And so it's useful, I think, to understand this context to start with. So let's try and break it down a little bit. So it's built into 4 different parts there. So you have a user, a role, a type, and a level. And so the user is what maps to some set of roles and a level range. The role is what then maps to a set of types, and the type is then what determines what types of processes and files you can access. And that's processes accessing files and processes accessing other processes. And then the really important one here for a multi-tenant PaaS is the level. And it's the multi-category security level is the longer way of saying it. And the example here actually is a longer form, which is you can state that as the sensitivity followed by the category range. And so the example there is saying for sensitivity 0, it includes all categories. So in the categories there's 1024 of them. So C0.C1023 is listing all categories from 0 to 1023. And that's for sensitivity 0 in that case. Okay, so now the trick is mapping that context to a user. And so the thing that we gain here with, actually let me go back. The thing that we gain here with the level is the ability to dynamically pick a context for a user. So with a platform as a service, you want to be able to create users on the fly, and users map to applications in the case of OpenShift. And so every time we go create a new application, or a gear actually is the better term to map it to, we will go create another Linux user on the operating system. And we need another security context to be able to map to that user, to be able to isolate that user to always running within that context, and always their files are associated with that context. And so the example of how we do that is, so for a user here where we have a UID of 500, whenever you list that user's files, you'll see that they have a MCS level over there of C0, C500. There's a comma in between, which means that it's the two categories together in this case, not everyone in between. And so the next user, if we were to go to user 501, they would have a category or an MCS level there of C0, C501, and that will continue up to C1023, and then it'll loop back around and have C1, C2, and you continue on until you use them all up, which there's quite a few there. And the same thing will exist for processes. And it's that simple mapping which enables us to dynamically create users, dynamically assign context to them, and then lock down that user to the particular files that they should have access to, the particular processes they should have access to, as well as the IP range and ports they're able to access. So some real simple tips here for those of you who don't know SELinux well. If you are having problems, there's an audit log available. Whenever you do a set enforce 0, you're setting SELinux to permissive mode. For those that don't know, actually, that actually can actually make your system slower in a lot of cases because of the way SELinux works. It'll actually make it keep going, even though a check fails, it'll keep going in permissive mode and tell you what else would fail. Whereas if you actually have SELinux enabled, it'll fail faster. But as long as SELinux is enabled and in permissive mode, it'll continue to run every single check that it would have before. But what you can do, whether it's enabled or not, or in permissive mode or not, you can always check the audit log for whenever you're getting various operations denied by SELinux. So that's always the first place I would go. And SELinux here, again, it's incredibly useful for PaaS, and it's an integral part of what we're doing with OpenShift. It's something that, again, incredibly powerful tool. We basically cannot live without it, and it's the only reason why I personally would trust a PaaS. Sorry about that. Would trust a PaaS to be able to handle a multi-tenant environment. And if you are still stuck, again, there's a lot of resources out there. I will warn you, it does take a couple reads through before I think, at least for myself, where I was able to fully understand it. But I would encourage you to go learn more about it, especially if you're going to get involved with OpenShift. And now I'm going to turn it back over to Krishna, and he's going to take us through a demo. Yes? Yes, that's the idea. So Linux containers builds on, sorry, let me repeat the question actually. So the question was that we are looking towards LXC as the future, and Cloud Foundry was the example that was brought up as somebody who's done similar. And it's definitely the case that we want to get there. So the way Linux containers works is that it builds up on top of a chroot, and it integrates with C groups and other technologies. We're really doing the same sort of stuff. But the problem is that Cloud Foundry doesn't have SELinux, right? And so what we need is LXC with SELinux. And until we get that, then we're sort of in this environment of the messy wires that I showed before, right? We're sort of creating what Linux containers is doing because it doesn't integrate with SELinux. Once LXC is there, then we believe it'll make our lives and everybody's lives a lot easier to be able to manage these types of environments. Now, the good news is that with OpenShift, we're doing a lot of the hard work for you. You will want to understand it, particularly if you're going to start doing the hosting yourself for these types of environments. But we are definitely looking forward to LXC in the future in combination with SELinux. Another question? Yes.
Isn't the big issue there a cultural one in that operations sees themselves as protecting the current service level and making sure it gets better, or at least gets no worse as you change things, whereas developers see themselves as making changes and changes being good. And that can be a cultural difference, which could make operations look obstructive, whereas operations see themselves as protecting the business as it's operating at the moment.
Yeah, I agree with you. I think it definitely is a cultural issue. I think that in some cases processes will have to change, right? We'll have to get to the point where, as part of using a PaaS, right, you have to prove to operations that things will work in some cases, right? So you can do deployments using the PaaS to some sandbox. Operations can look at that and verify that they're happy with it. It's also the case that because the PaaS is defining what an application looks like, it's really that language of here's what operations expects in some language that's clearly written out, right? Of here's what files you must have, here's what configuration you must specify. And then it really is the case with a platform as a service that operations has to be aware of every one of those configurations that they allow and be comfortable with it. It's not, and again, it goes back to the standard deployment thing, right? Of a PaaS is a well-defined set of things of what it supports. And really operations needs to be able to well-define that list for the developers they want to support. And so it's only the things that they want to support that they should put in that list. And then they really are limiting what is possible, and they're forcing developers into a particular line of thought.
The other thing I got from this with SELinux and so on, that the PaaS is actually a much more predictable or stable environment for applications, and it actually takes away a lot of the risks. It's actually less risky, not more risky, if you put SELinux on everything.
Absolutely. That's certainly the goal and what we believe we've done.
It's also the reverse of how traditional Unix permissions have been working. So they are more, let's figure out what we want to allow. SELinux basically says everything's locked down till I say it must be okay. In Linux permissions, everything's open till you lock down what you want. So SELinux ends up being more secure that way.
Again, very much the operations mindset versus developer mindset.
Any other questions? Feel free to ask questions as we go also. Yeah?
Yeah,
Yes.
it was listed as one just for simplicity because we have a lot of nodes, but the broker scales as much as you want.
Yeah, so the broker itself is stateless. All of the state is maintained in Mongo, and Mongo can scale as well. So you can have as many broker machines as you like, and you have a replicated Mongo installation, and then you have multiple nodes. So.
You're talking about HA proxy used by the applications. Yeah, not yet. We will get there. At this point, when you do scale, we don't support a full HA setup yet for scaling. It's certainly on our roadmap. We're not quite there yet.
Yeah.
Does the broker handle load failures?
There's a lot of things that are handling the gears themselves running on the nodes. The broker itself is not doing deployments or anything on the. It's not spinning up new nodes, for example, at this point. That actually is another area that is on our roadmap, not available yet. So at this point, spinning up new nodes is.
You didn't need nodes. You meant move the gears onto a different node. Like if a node goes away, we'll make sure the gears are running somewhere.
So.
If the node fails, will the gears be started? If we're running on that node, will those gears be started on another node that is weak?
If it is a scaled application, right, and one of the web server nodes fails, whenever the next scaling event happens to take place, it will spin up a new one.
Yeah, I think that's true, and I think the right answer is that there's still a lot of room for improvement that's going to happen there, right? So As soon as we support a full HA setup, that will absolutely be the case. As of right now, there are plenty of cases where there's one gear that's all you have, and if that node dies completely and it hasn't been backed up, then there's nothing the broker's going to do to solve that problem.
Yeah.
Definitely the problem space we are in and that we want to solve, though.
So for the demo, I'll basically be showing you spinning up OpenShift origin ISO within VirtualBox. You can really use anything. I've had questions asked whether it'll work in Eucalyptus. Answer is yes. It'll work on VMware. It will work on Parallels. It doesn't matter. It's pretty agnostic about what the underlying platform is. So the first thing you do is, of course, create a new virtual machine. And we are running it in a 64-bit version of Linux. So you have to choose 64. It will not work on 32. The ISO image uses a RAM disk. So to do anything useful, even having 2 applications on there, you want to give it enough space. So I typically go with either 2 or 3 gigs over there. If you install this onto your hard drive, you don't really have that restriction anymore because then it's not using the RAM disk anymore. So since it's using RAM disk, I'm not going to start with the hard drive. That's created and started, and it'll then ask me for where the ISO is. So this is taking a couple of seconds to boot up. What this comes with is a built-in DNS service based on bind, authentication based on Mongo. This particular ISO is built off of a branch which is running mcollective. It's already on a branch, it's just not merged into master. Right, so this has mcollective and Cupid running on it for broker to node communication. In this case, broker and node are sitting on the same machine, so it's not much. Oh. Yeah. So this first one that comes up, this is really, VirtualBox doesn't support 3D, so it's complaining a little bit. Yeah, let me scale this up so everyone can see. It's going to look a little weird just because it's scaled. But when the CD boots up, it comes with really links to all of our other projects on GitHub, as well as links to documentation on our community site as to how to set up your own stuff, your own version of Origin. So for this demo, I'm going to be doing a WordPress installation, and I'm going to use one of the quick starts that's on our GitHub repo. So every quick start that we have on there comes with instructions. It's about 4, 5 things that you have to do to actually get it up and running. But let's get started. So when you start the Origin ISO, it comes with a built-in user, and this is the admin user admin, password admin. There is a command on here, ss register user, where you can add additional users into Mongo. But I'll just use admin, and the first thing I'm going to do is create that namespace. You create a SSH key, and this allows you to do a git push. So all applications within the same namespace will use this SSH key. If you have multiple developers, you can register additional SSH keys with the same namespace. I wonder if, let me start this up again. I guess there's a error on startup.
The question that was popping in my head is, maybe you can answer this when you get the number ahead. How would you handle SSL certificates?
Mm-hmm.
Do you dynamically create one for each domain that gets fired up? Do you use like one for the base domain name?
I'll answer. Yeah, so the question is, how will we handle SSL certificates? So I know right now I think we allow you to piggyback on ours. So that's the only solution we have currently available. I believe what we are trying to do, well, we're trying to add something longer term to enable you to, for us to enable you to give us your keys essentially and let you use your own. Yeah, I'm pretty sure, well, I hate to say this, I'm pretty sure that was announced as part of the paid offering that's going to happen later in the year. So it will be available, but right now all we have is piggybacking. Yes, that's correct. Yes, it's one.
So that would be via Elastic Load Balancers and Amazon. If you want to be able to publish your SSL cert arbitrarily for customers, would you be using that, or are you using something not?
I don't think we will be using Amazon for it, but I'm not positive. There's actually people in the back of the room. I'm sure they can answer that question better than I could. If you want to hang around afterwards, I think we could.
Okay, so let's go back to GitHub. So after the domain is created, I'm basically going to be creating that application. That's the wrong command. This one. So it's going to be creating a PHP 5.3 application, and it's calling it WordPress. Right? So if you're on the public hosted service, then this actually registers the DNS name with it. In this case, it would be WordPress-mynamespace.rhcloud.com. Within the live CD, it's .example.com. Okay, so after this is up, you can actually go and see what's there. And it's just going to be a placeholder page which tells you what to do. In my case, I'm going to be pulling down code from GitHub and then pushing it back up here. But you can change code directly on here as well. Right, so since it's WordPress, it uses MySQL. Let's add that as well. And over here you have, as far as databases go right now, we have MySQL, Mongo, and Postgres available. They run on gears. So if you have a scaled app, the database will be on a separate gear. Right. Yes. So you'll see a whole bunch of files scroll by. This is basically just pulling down the code from GitHub and merging it in to the branch. And then I'm going to do a git push, and this will push it up. Every application comes with a set of hooks that you can customize. So if you want to do any additional work, like doing migrations, you can do that in the post-deploy step. Or so we can. I think we have pre and post steps for starting, stopping, deploying, things like that. Right. So we did the push. We go back up there, and you can see WordPress up. So to answer your question about the database being on different gears, if you actually SSH into the machine and run the env command, you can see what environments variables are available for you to use in your application. So in our case, we had MySQL. Let's see. So the database URL is there, and it'll also have the password and right. So it'll have the commands to dump, restore, password, all of that is available to you. So within your application, you should be using the environment variables rather than hard coding the location, because these things might move around. And if you have, especially if you have a scaled application, as new gears come up, these environment variables will reflect what needs to happen. So that's the demo. Done. Let me go back.
You were talking about balancing an application. You said that the same application could be running in gears and have a gear that care of balance.
Yes.
Is this available right now, or is this?
Yes. It's available right now.
I mean, is this in the free shift, in the free available, or something?
So the free option of OpenShift has 3 gears on it. So if you create an application that's scaled over there, it scales from 1 to 2 because one of the gears is already occupied by the HA proxy.
And when you log in to SSH, where are you logging? Which gear?
The SSHO here will give you the login into the HA proxy gear. But there are, if you explore the REST API, that will list all of the other gears for you as well.
You mentioned that the application still slow gears. Is this also true for database applications?
So right now, that is not the case, but that's something that we are working towards.
Yeah, I mean, it would be MySQL master slave. Mongo will probably do replica sets and sharding. Yeah, so we have some links up here just to be able to download the CD, join the forums. Again, we encourage you to be active in the forums, the mailing list. We stay on IRC pretty much all day long. And again, we want your pull requests. So if you have changes, then please feel free to submit them.
Especially to the operations people, you probably know more about operations than we do, so it's a good time to contribute early in the project. So.
Yeah, we have our operations guys back there, so if you have the tough questions, we're going to send them to them.
And yeah. So we are slowly putting all of that documentation up on our community site, and that gets cleaned up some more and then put up on the Red Hat docs site as well.
Yeah, and I know we actually have a goal to get our long-term plans, or even our short-term plans, to be out on something external, so everybody can go see what we're planning and when we're expecting it to be done. So you can at least know what's coming next and what we are thinking about. I know there was some talks here too about what the future is, so don't know. Those presentations I know are posted out there if you want to go take a look. Yeah.
There is. Yeah, so if you go to OpenShift.com, community, and then open source, and all of the documentation, the architecture docs, all of this is available here.